Hello guys, in this video we are going to discuss the solution of the problem find each index. So let us look at the problem statement. The problem statement says given an integer array citations where citation I is the number of citations a researcher received for the ith paper, the task is to find the h index. H index is the largest value such that the researcher has at least h papers that have been cited at least h times. So for instance, if this is the citations array which is given to us, as we can see that there exist 3 papers which were cited at least 3 times, because of which we are returning 3. Now let us try to understand the problem statement little bit further. So let us say this is the citation array which is given to us. With this citation array, we are going to prepare this table. This table contains paper index and the number of paper with at least I citation. So for instance, if the paper index is 1, we are looking for the numbers of papers with at least 1 citation. So as we can see, there exist 3 papers with at least 1 citation, because of which 3 will be over here. Similarly, when paper index is equals to 2, we are looking for paper with at least 2 citations. Again, these 3 values are going to satisfy that, because of which 3 will come over here. And similarly, for 3 it will be 3. For paper index 4 it will be equals to 1, and for paper index 5 it will be equals to 1. And in this way this table can be populated. Now with this table we are going to find out our h index. So remember, h index is the largest value of paper index. So the largest value of paper index such that I paper has been cited. So for instance, if you look at this, 1 has at least 1 paper cited over here. Since the value is 3, so at least 1 paper has been cited. So this is a possible candidate for us. Is it possible to find a larger value than 1? So let us look at that. Now again 2, for paper index 2, the number of papers cited over here is 3. So this also satisfies the condition of h index, because of which our h value will be equals to 2. Now let us see if it is possible to find a value larger than 2. Now for 3, as we can see, the value over here is 3. Since it satisfies the definition of h index, because of which our current answer will be equals to 3. And as we can see further, for 4 and 5, the h index definition is not satisfied. So for 4, the number of papers cited at least 4 times is just 1. Since this value is not greater than or equals to 4, because of which h index definition has not been satisfied. So this value cannot be considered. Similarly, this value can also not be considered. So among these 3, the largest value is 3, because of which we are going to return 3 over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, what we are going to do is we are going to prepare a frequency array which contains the frequency of the ith paper. Now with this frequency array computed, what we are going to do is we are going to compute our h value. So that's the general idea behind solving this problem, folks. Now let us take an example to understand this. So let us say this is the citation array which is given to us. Now with this citation array, we are going to compute, or we are going to prepare a frequency array. So let us do that. And folks, the size of this frequency array will be equals to len of citations, and we will discuss y plus 1, but for now let us proceed forward. And now let us prepare our frequency array. So first let us compute how many papers are there with 0 citations. So there exist 2 such papers. How many papers are there with 1 citation? So there isn't any such paper, because of which the value will be equals to 0. How many papers are there with exactly 2 citations? Again 0. How many papers are there with exactly 3 citations? So 2 over here. For 4 this value will be 0, and for 5 this value will be equals to 1. Now with frequency array populated, what we are going to do is we are going to compute the value of h index. For that, let us have paper index over here and the number of papers with at least I citation. So let's start from the last paper. Since we have to find the largest value, so we are going to start from the last paper. So the last paper index is 5. The numbers of papers with at least I citation is just 1 paper. So this value will be equals to 1. Now since this does not satisfy the definition of h value, because of which we are proceeding further. So the next paper index which we have is 4. Now let us compute the number of papers with at least 4 citations. So the number of papers with at least 4 citation will be given by the summation of these two values. So over here this value will be equals to 0 plus 1, which is equals to 1. Again, this also does not satisfy our definition of h index, because of which we are proceeding further. Now with 3, the number of papers with at least 3 citations are given by the sum of these 3 values. So this will be equals to 0 plus 1 plus 2, which is equals to 3. And folks, as we can see, this satisfies the definition of h index, because of which we are going to return 3 from here. And that's the whole idea behind solving this problem. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to compute h index and a citation array is given to us. With this, let us have n is equals to length of array, and then let us declare our frequency array. So for frequency array, 0 for in range of n plus 1. And then we are going to prepare our frequency array. And to prepare our frequency array, let us iterate on the citation array. So for element in citations, over here, all we have to do is if element is greater than or equals to n. If that is the case, then we are going to designate all such papers at the last index, which is frequency of n plus 1. And that is the reason, folks, why we were using n plus 1 rather than n length array. Otherwise, frequency of element plus equals to 1. And in this way, we will be able to prepare our frequency array. Once the frequency array is prepared, then we are going to compute our h index. To do so, all we have to do is we have to take answer, which is equals to n, and then the sum so far. So the sum so far is frequency of last element. So frequency of n. So folks, over here, I am starting from this position, which is 5 is the value of answer and the sum is 1. Now, with that, we are going to iterate on answer while s is less than answer. If that is the case, all we have to do is we have to reduce answer by 1 and we have to compute s, which is equals to s plus frequency of answer. And towards the end, we just have to return answer. So folks, over here, all I am doing is, so let us say this does not satisfy the definition of h, then we are going to the next index, which is 4, so answer minus 1, and then we have to compute the summation of the last two elements, so 0 plus 1. That is why s is equals to s plus frequency of answer. And towards the end, we are returning answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. Over here, n is equals to length of citation, and then we are defining frequency whose size is equals to n plus 1. Then we are preparing our frequency array, and then we are computing the h index. And the way we are computing the h index is answer equals to n, s equals to frequency of n, and then while s is less than n, answer minus equals to 1, and s equals to s plus frequency of answer. Towards the end, we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Frequency vector is there, answer and n is there. Then we are preparing frequency array, and towards the end we are computing h index and we are returning that value. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.